Hello, and welcome to the Lofar Galaxy Zoo tutorial. In this universe project, you get the chance to help astronomers locate and identify supermassive black holes. In this video, we'll be showing you what exactly you'll be looking at and how to make your first classifications. Feel free to move this video to another screen and to click along with us as we walk through the steps. If you only want to see a specific part of this video, you can use the timestamps in the description to skip ahead. When you're ready, go ahead and get started with your first classification by clicking on the Get Started button. The first thing that will pop up is the tutorial. Be sure to follow along with this video using the special tutorial workflow by clicking on the link in the tutorial. Since you are watching the tutorial video right now, you can go ahead and close the text tutorial by clicking on the top right of the tutorial. Then you should see the same image as the one shown here. You can always open it again later by clicking on Tutorial. Now, let's talk about what we are looking at. The image in the center of your screen is made up of different parts. The optical image in the background, the yellow contour lines showing the radio emission, and finally the blue ellipses. The optical background image will be mostly black, with some white shapes. The white shapes that you are seeing are galaxies and in some cases stars. It will also contain small squares, pixels to be precise, that appear red, green, or blue, or you might notice other shapes such as red streaks. These are a byproduct of generating these images, and you do not need to pay attention to those. The yellow lines that you see are called contour lines. They represent the radio emission that is reaching us from this part of space. These are the signals that we are receiving from the supermassive black holes. As you may notice, these lines tend to form shapes. The elements of these shapes are indicated by the blue ellipses. Our aim in this project is to find out from where these shapes originate and which ones belong together. How we do this, I will explain later. First, we are going to take a look at the other buttons on the screen. If you already know this, you can skip ahead using the timestamps. Let's start by looking at the bottom of the screen. In the center, you will see three circles. The first circle shows the initial image. Clicking on the second circle shows the radio emission as a color image for if the contour lines are confusing or if you just want to see a pretty image. Finally, clicking on the last circle shows only the optical image without the yellow contour lines. You can also automatically switch between the images by clicking on the play button on the bottom left of the screen and adjust the speed using the slider. On the bottom right of the screen, you will see several different buttons. The first of these allows you to invert the color of the image. The second allows you to see some basic information. You do not need to pay attention to this outside of the tutorial workflow. The heart lets you favorite the image, allowing you to save it in your favorites folder under the Collect tab. The last button allows you to add the image to a specific collection. A customized folder, if you will, in case you want to group certain types of images together. On the top right of the screen, you can see different buttons that allow you to manipulate the image. Pan, zoom in, zoom out, rotate, and finally reset the image to its original view. Now that we know how to handle the image, we can move on to the classification. The first task is named Component Selection. Remember that all of the blue ellipses that you see in the image are different parts of the yellow contour lines that we believe belong together. The goal of this first task is to select all of the dashed ellipses that you believe belong to the same structure as the one ellipse with a solid line. You can do this by clicking on Component Selector and clicking in the center of the ellipses that you think belong together. If you need to, pause the video at this point and try this for yourself. Do not worry about misclicking. You can always move the marker to another ellipse or remove it entirely. The typical shape of the structure that you are looking for is two adjacent lobes, like in this example image. These lobes are formed by the radio jets emitted from a central supermassive black hole. The tutorial workflow will show you more common examples. You can also see the field guide on the right of the screen for more examples of structures that you may be looking for. In this case, all the dashed ellipses are part of the two-lobed structure. Click on all of them to associate them together. Once you're done with this task, you can move on to the second task by clicking the Next button. In this tutorial workflow, you will receive feedback on your clicks, but this will not be available once you start classifying for real. The second task of this classification is optical identification. This means that we will be trying to find a galaxy in the optical image from which the radio emission, the yellow contour lines, might originate. This galaxy contains a supermassive black hole that is producing the yellow contour lines. In order to do this, click on Host Galaxy Selector and then click on the galaxy that you believe the radio emission is coming from. Note how in this example image, the host galaxy is located in the middle of the two radio lobes. This will often be the case. It may happen that the yellow contour lines block the optical image. In this case, you can use the tools in the bottom of the screen that we mentioned earlier in this video in order to toggle the yellow contour lines on and off. You might encounter images where there's no obvious host galaxy. In this case, you do not need to select anything. Once you're done, you can move on to the third and final task by clicking Next. Again, during the tutorial, you will receive feedback on whether you selected the correct optical source. The third and final step allows you to let us know if there's something which stopped you from being able to complete the previous two tasks. The different problems you may run into are listed below the description of this task and will be covered later in this video. See the button Need some help with this task or the field guide for examples of these potential hindrances. Remember that you are allowed to select more than one button. If nothing is wrong, you do not need to click on anything. Once you're done with this task, you can either choose to move on ahead to the next image by clicking Done, or choose to discuss this current image with other people by clicking on Done and Talk. Congratulations! You're now ready to go on classifying by yourself. If you need more help, do not hesitate to follow along with the rest of this video, where we will show more examples of radio sources that you might encounter. You can also always check out the field guide or the tutorial, or send us a message in the talk section of this project. If you feel ready to start, we wish you happy clicking. Otherwise, click Done and follow along with the next images. The second image in this tutorial is basically a zoomed out version of the first image. Since most radio objects are far away, it might look like the two lobes are touching, with little or no sign of the narrow emission in between. In this case, the dashed ellipses are overlapping the solid ellipse. If you can, try to click inside only one ellipse at a time. If this is impossible, just try clicking as close to the center of the ellipse as you can. The other dashed ellipses in this image are unrelated to the solid ellipse, as the shapes of the yellow lines are different and do not touch. These are separate radio sources. You should not select these. As before, if there is an optical counterpart source, it is normally located in between the two lobes. The third image shows an asymmetric source. This can happen when the radio jet is pointing directly towards us, or when the jets are swept into a tail on one side of the black hole by some external shocks, or because it is moving through space very fast. In this case, the solid ellipse is a little bit next to the source, but we can be reasonably sure that all dashed ellipses correspond to the solid ellipse. A good strategy for identifying the optical host is to look in places where the radio contours are packed tightly together. Tightly packed contours indicate brighter radio emission, which might indicate a nearby power source. The source can also still be quite symmetric. but the radio jets might be bent because the black hole is moving through space very fast. In this case, the solid ellipse correctly encompasses the entire source, so we do not have to click any dashed ellipses. The optical source is again found in the middle of the radio source. While most images in the Lofar Galaxy Zoo show radio emission coming from a supermassive black hole in a distant galaxy, you might also encounter radio emission from stars and gas in nearby galaxies. Nearby galaxies appear very large and much more detailed in the optical image, and the radio emission usually follows the optical emission closely. The optical host is very easily identified as it covers almost the entire image here. You might also encounter emission that does not really have any compact structures. This is often also not caused by a supermassive black hole, but can be emitted by, for example, a cluster of galaxies. Therefore, there's often no optical host galaxy, so you don't have to do anything. By clicking through to the end, you are still contributing by letting us know that there is no optical host. This source is an example of a complex case. At first glance, it seems like a single radio source with two jets. But upon looking at the optical image, it seems that each blue ellipse has its own optical counterpart. Therefore, most likely, this is actually three separate radio sources that just happen to be close together. We therefore don't want to associate the components. The optical counterpart of the solid blue ellipse is behind the compact contour here. This is an example of a source that is too zoomed in to classify. A part of the radio emission is outside of the image. Therefore, we don't want to click anything for the first two tasks. For the last task, select Too Zoomed In. Here is quite a messy example of what are likely artifacts from the imaging process. These radio contours are not mapping any clear structure. We can select everything that does not seem like a real radio source. The image also contains some real radio sources that have multiple compact contours and even an optical counterpart. We do not want to select those. Because the contours are artifacts, we cannot select an optical host galaxy. Finally, select artifacts to let us know that something went wrong with the image. As the last example, you might encounter cases where the optical image is missing. In this case, still try to associate blue ellipses as well as you can, but select optical image missing in the last task. Congratulations! You are fully trained and ready to go on classifying by yourself. If you need more help, do not hesitate to follow along with this video one more time or consult the field guide for more help. You could also always post your questions on the talkboard. We would like to thank you for your interest in this project, and we wish you happy clicking.